let's take a look at this butane molecule here. So as we do that, what I'd like to do is I'd like to look at it down this carbon bond here. So the 2 here and the 3. So that's what I want to kind of look at here. And let's just circle that and we'll make that kind of red in the background. All right, so as we look down that bond and draw our first structure, we're going to see that this methyl group here and this methyl group are eclipsed with each other. So we have a CH3 pointing up in the back and a CH3 here in the front. That's this CH3 here. So we're going to start off looking at this particular conformation of butane. So it's a high energy conformation. So we can see here we have a CH3, a carbon, and another CH3. And what we're going to do is we're going to look down this carbon-carbon bond, the 2,3 bond. And if you see that, you can tell in this orientation here that we have a CH3 in front of another CH3, H's eclipsed, and H's on this side also eclipsed. So what we see then is that these are our H's. And because these are the large groups, these groups are really large, methyls are large, right? Because of that, that's going to make this conformation what we call totally eclipsed. Right? And then again, we can choose to rotate the front or the back, but I'm keeping the back constant here. So that CH3 we're going to leave right there, and the H's and all that stuff on the back carbon will remain constant. Now that CH3 that we have here is going to come over to this position, so that goes here. That means that those H's are moving over. Right, so this conformation is called gauche, G-A-U-C-H-E. Right, again, so here we have another dihedral angle of 60 degrees right now relative to these two large groups. That's what we'll use for the point of reference here. We're going to do another rotation, so that's going to come down here. So this is going to be a CH3. This is another eclipsed, an H and an H. Now the eclipse conformation here has a big methyl group with these smaller H atoms. So even though it's eclipsed, it's not as bad as the totally eclipsed. So this is eclipsed. And then lastly, we do one more rotation where this moves over here. So our H's are on this side. So here we have a CH3 group that's very far from this other CH3 group. Right? So if we go through our angle, this is 60. Here we have a dihedral angle of 120. So these are 120 degrees from each other. And here you can see that we are 180 degrees away from each other. Okay, so let's take a closer look at that on this little animation here. And next, if we do a rotation, we went from this eclipsed position up here over to this position, which is gauche, and we have a 60-degree dihedral angle there. So we can see that that bond's been rotated down. Now what we're going to do is we're going to do another rotation. That's going to take this H and pull it down to be eclipsed with this. So let's see what that looks like. Now that'll give us another eclipsed conformation, but if you can see here, the eclipse that we're getting here is between a larger CH3 in the background and a small h. And then on the front side you have a larger CH3 represented by this gray atom and a smaller H on the back. We're going to do another rotation and pull this down so that it's opposite of this CH3. So let's see what that looks like. This is our molecule right now, looking down the C2 to C3 as we did before. We're going to pull that around and look at this, and that would be our anti-conformation, and that has a bond angle of 180, a dihedral angle here of 180. And then at that point in time, we're just going to continue. So a further would take this and put it eclipsed, right, with an H here. This would come up and be eclipsed with the CH3, and the two H's would be eclipsed down here. And we start to repeat ourselves as we go around this next rotation. So we're going to start off here. We've seen our totally eclipsed conformation, right? We've seen our gauche conformation, our eclipsed conformation, And then over here, we have our anti-conformation. All right, so here's our anti. Now, I've plotted some energies for us down here below, and we have some skeletons to fill in, some skeleton templates for our carbons and our H's here. So what we're going to do is we're going to start off with that totally eclipsed conformation that we started with up above, and that would make this a CH3, right? And then this would be an H atom, and then this would be another H atom. Now we're going to keep the back stationary, and we're going to rotate here. So what we're going to do is we're going to take this first CH3, and we're going to move it over to this position. So that's going to be a CH3 here. Right, the H is going to come over. It's like you're turning a steering wheel, right? And the H is going to go here. And then we have this coming over to this position, so we get this. Right, and that gives you, again, your dihedral angle there of 60 degrees. And now again, we're gonna pull this thing over. Now this totally eclipsed, by the way, this is going to have a fairly large energy because the CH3s are big groups. Right, and then you have this large group back here behind here. So those large groups that we have here are going to have a lot of steric repulsion between each other. H's are smaller, but carbon is a larger atom and it has 3 H's sticking off of it. Right, so here's our CH3. And we're going to continue to do that rotation. So we're going to pull that CH3 around, this H over here, and then we're going to swing around here. That'll give us that eclipse conformation that we saw in that little JMO video that I showed you guys a second ago. So what that's going to do is that's going to put our CH3 here, right? And then our H is going to go there, and we're just labeling them so that we can keep track of them specifically, and that's another H that's right there. All right, now CH3 comes over here. That gives us anti. So now our CH3s are 180 degrees away from each other. So this is also staggered, but it's lower in energy because the CH3s are 180 degrees from each other rather than this 60 degrees as we see over in the gauche conformation. And our eclipsed here is going to be lower in energy than totally eclipsed, right? Because what we have now is this large CH3 with a smaller H atom kind of behind it. So we're eclipsed, but it's it's like a large planet and a small planet kind of behind it. So we're going to continue that rotation. H is going to come around up to this position, and this H comes over to that position. And at that point in time, if you look at the diagram up above, really what we're doing is you're taking this and folding it and repeating it over on that side, right? So it's just a repetition. So kind of moving through this, our CH3 would be here. Right, that H comes up here, and H moves over to this position, right? So again, kind of moving through this, H comes down, CH3 comes over, H comes up. And now we're pulling this H down to this position. This H here is going to pull over to that position, so we get our H here. And then this CH3 that's here comes over to this position. And that gives us another gauche, right? And then the last one will be our final rotation, which takes us back all the way back home to totally eclipsed. So that CH3 moves over, this H here comes to this position, and this H that's here moves over to that position. And then that would give you another totally eclipsed. Now, there's an important thing to point out to you guys here. And the first thing is that the staggered conformations are always lower in energy than the eclipsed conformations. So this is always true. And the other thing is that we typically want to have the largest groups farthest apart from each other, right? So that anti is our lowest in energy because the large groups are 180 degrees away from each other. So this kind of applies really to the conformations of other molecules. This is why we zigzag them, right? So if we look down this carbon bond right here, right, this CH3 is going to be 180 degrees away from this propyl group, right? So they're anti to each other. And that's in principle why we draw these things out with our zigzags.